Okay, hi and welcome to my presentation of Lab 4, where we are supposed to use GA to evolve agents in several generations. Um, I will not talk so much about the beginning because it's the same as always, sort of. We make a maze um, to be able to have something to work with. I have a maze class which holds the maze, and I have a minion class which is the agent, and the minion class holds the minion, and it also holds the functions for moving the minion. I have an update policy, I have a reset minion, add policy, and a function to see if the minion has solved the maze. I will talk more about the move function and the update policy if the time is okay. Begin with, I make a breadth first search of the maze to get the target amount of steps, which is the ultimate solution of the maze. I then have the fitness function which gets called from the program and gets past the current minion and the target, and the target is the ultimate amount of steps to clear the maze. And in short, it gets a fitness score where it compares the distance of the minion to the target distance. And if the minion has the same amount of steps as the ultimate target, then it gets a fitness score of 1. I have a policy which generates a policy for the maze. It gets the height and width of the maze and has 4 directions with probabilities for each direction. From the start, it's just 1 divided by 4. I have a function to mutate the policy, uh, which takes me, which is the mutation rate. So that's the probability for a certain part of the policy to be mutated and randomized, and it has to normalize it after that. And this is the mutate minion, but what that does is just mutate the policy in short. So the program, I declare a couple of variables to have the start position, the width and height of the maze, and such. Set the population size, mutation rate. I've done 150 generations in the run I will show. I make the population and populate it with minions, and every minion is of the minion class, and every minion has its own unique policy, which is generated also. And when I've filled up my population with 100 minions, I go through the generations, and for each minion, I the minion tries to solve the maze within 1,000 steps, and from the policy, it gets the current policy for the minion's position, and then gets a random action with the probabilities from the policy, and it then moves the minion with the action it got, so to say. It moves the minion, um, and it gets the maze solved from the minion class, and if it does that, it goes well, it depends to an alive list I made. It depends the fitness function or fitness score of the minion to W, and then I keep track of the numbers of the minions. Um, if all died, it generates a new population to start all over. It well, depends everything, so to say, gets the best overall, gets the best score, and then I for the I iterate through the population size, in the evolution, and I take, for the two first, I take the minion with the best fitness score, and well, passes that minion to the next generation, a copy of that minion to the first two. And then I always think it was called a tournament selection, where I first randomly pick a minion from the population, and then I randomly pick another one, and the one with the best score gets to evolve or get evolved to a new minion. And I copy it to the new minion. Then I update the policy, and what the update policy does is that um, it goes through the current minion's route that it took, and for each good selection or good move, it gets a little boost in probability to make that move again. And that with the update policy, that gets passed down to the next minion in the next generation. This can be excluded. This is just a little boost to the evolution process, or so to say. This can be excluded, and the GA will work anyway, and maybe it will be a more pure GA. It will be a lot slower, but it will still work. And then I reset the minion to get the minion back to its starting position, set its route to blank or 0, and set the distance to 0 too. And then I mutate the minion, which in fact what it does is it mutates the policy with the probability of me, and then it appends the minion to the next population. And when it has done this for the whole population size or population range, it sets the population to be a copy of the next population, and then it all starts over again. And for each population, or for each generation, I print the best minion to keep track of things. And then I print, when it's all done, print the best overall. I print the best minions route to see how it went, and then I plot. So here I made my breadth first search just to see the best path, the ultimate path, and the target is 36 steps. And here I have printed out my generations with the best minion of each generation with its fitness score, which minion it was, and the distance for that minion. So now I can follow each generation, and we can see a decrease in distance and an increase in fitness score. Then of course it goes a little up, a little down, so to say. And in the end, we can see here in generation 90, we got an ultimate minion which took 36 steps, had a fitness score of 1. But then, thanks to the mutation, it goes a little up and down. So next generation, the best minion had 40 as distance, because it mutated its policy a little bit, although it inherited from the minion with 36 steps. Something got mutated, so it took a little different route. And as we go, we can see that in the end, the best minion always is an ultimate minion, almost always. And we can see the path of the best minion, and we can also see the max score of the max fitness score. We can see a steady increase, and here it gets up to 1, so it's ultimate. And then a little dip because of the mutation. But we can also see that not every minion has this max score. The mean value also increases steadily, but we can see that in the whole population of each generation, we have a spread of fitness value and distance. So not every minion is the perfect minion. Well, I'm sorry for taking a long time for the video. I hope everything was clear, and that it did what it's supposed to do. Thank you for me, and have a good time. Bye.